Hi, good afternoon, everyone. We're here at Founders Fund in the Presidio for our panel on superintelligence. And it's sure to be an awesome talk. I'm Jessica Lessin, founder of The Information, a technology publication. I'll quickly introduce our panel and then we'll dive right in. So we have Paul Dabrowski, who is the CEO of Synthego, a very exciting company that is broadly trying to kind of reinvent, create a new platform for scientific research generally. Is doing some awesome work with RNA and thinking about how that can help us on our path towards superintelligence. Hopefully we can talk more about that. Luca Novick, partner at Founders Fund and the resident AI expert here, was an early investor and board member of DeepMind before it was acquired by Google. So deep expertise in the space.
And also
investor in Vicarious, Scott Phoenix, the CEO and founder. Somewhat stealthy, co-founder. Somewhat stealthy AI company. It's been around for a while, really a pioneer in the space as well, and taking somewhat of a different approach than some of the deep learning approaches that we hear a lot about in AI. So thank you guys for being here.
Absolutely. Thanks for having
us. Thank you. To start, easy softball question. What's superintelligence? What is this quest we're kind of after before we start to unpack where the technology is? Scott, I'll give it to you first.
It's a great question. I think there are a lot of kind of confusing definitions out there today. The one that I like best is, given human sensory experiences that we all get from birth to adulthood, write a program that takes those and is able to learn the same concepts and perform the same kinds of actions that you and I can perform.
Simple and hard at the same time. Would you guys agree with that, or how would you refine it?
That would get you to equivalent human intelligence rather than superintelligence. But I think what's very interesting about it, and it's Scott, maybe speaking for you here, but is that if you were able to create a computer program to do that, which is to create an equivalent human intelligence, because of the inherent programmability and the transferability of data and the transparency of what's going on inside of a computer compared to what's going on inside of a brain, quickly afterwards, you would expect superintelligence.
Yeah, as a society and as a civilization, we're really good at taking something that works and making it a lot faster. And so I think an implicit step after building human-level intelligence is getting to superintelligence.
And I'd broaden the scope and make sure that superintelligence includes humans also. So I guess this is partially the voice here coming in from the AI side. We're building intelligence, but I think we can also push the boundaries of our own intelligence and make sure that we're able to do things that we previously couldn't. And that includes intelligence, and that includes effective action, and even our perceptions could be improved significantly.
Yeah, okay, ambitious stuff. So where are we? A little bit of like a reality check. 2016, where a lot is exciting. Everyone seems to have their imagination piqued by AlphaGo and all of that, but where are we really? Give us the honest state of play.
It's a funny thing. It seems like every day I see an article in the news about how AI is done or is close to done or it's taking over the world. And, I think there are a lot of really interesting things happening, but I also think it's important not to get ahead of ourselves. So broadly speaking, for people in the audience who aren't familiar with deep learning, what it's generally doing is taking a really large labeled data set, say of photos, and learning a mapping between that labeled data set and a set of, let's say, category labels like cat, dog, car, bus, and so on. And that's a useful thing if you want a program that takes photos and labels them. But it's not really a useful thing if you want to have a robot that interacts with the world and predicts what's going to happen next and has a complex understanding of cause and effect relationships the way you and I do. And so I think there's a bunch of leaps that need to happen in the kinds of AI that we're building in order to get to a world that's full of robots and intelligent machines that can behave the way you and I would expect an intelligence to behave.
And are those the leaps that have existed forever? I mean, are we making any sort of sequential progress, or is it like progress is made over here, but nothing meaningful can happen, or not the kind of superintelligence doesn't happen until all this other stuff happens?
I think there's a lot of building blocks that are being constructed all over the different research communities that are working on them. I don't think that there's some fundamental new branch of math that needs to be discovered or something like that. But I think that many of the techniques that are being created now and being developed are steps in the right direction, and we need to continue to build on them. And I also think that we need to focus on making sure we don't oversaturate on one branch of the tree. Like deep learning is a technique, and it is capable of some things, not capable of others. And I want to make sure that we don't overinvest or overfocus on just these sort of simple big data A to B mappings. The figure I like about AlphaGo is that in order to play Go as well as a 33-year-old human, it had to play Go continuously for 3,000 years. And it only can play Go, it can't play checkers, it can't drive a car, make a sandwich. And so we've got a lot of work to do to get to something that has human-level training complexity and generalization.
What are some of the other branches? So we hear a lot about deep learning, but for you guys are the experts. I mean, what are the other stuff we may be hearing about soon?
Well, there was another aspect that was built into many of Google's algorithms called reinforcement learning. And that's essentially, in a human or an animal system, the pleasure and pain system, or the dopamine system, where you do the things that do more of the things that give you a reward and do less of the things that give you punishment. And actually tweaking something like this is a very, very new thing in computer algorithms, and getting them to take in information from the world and see whether it's getting them closer to winning a game or closer to making a part that you wanted to make or something like that. But I want to point out an interesting thing about these algorithms, deep learning and reinforcement learning, and deep learning in particular. And this is a question about like how smart are we, how good are we as humans at figuring this stuff out and figuring out intelligence? And I would say we're not that good, and maybe even getting worse. The example of deep learning, it's a very old algorithm. It's based off of neural networks. And neural networks were 70s, maybe even 60s?
Yeah, 60s, 70s. I mean,
it's been around.
Yeah, there's many different lineages.
There's many different lineages of it. And there were a few scientists like Jeff Hinton who kept pushing it over the decades. But there's an important point that happened in science where I think Seymour Papert started neural networks, and then Marvin Minsky, who was a very famous AI researcher, basically smashed it down and said, no, this is bad, we shouldn't focus on it for X, Y, and Z reasons, it doesn't matter. And because of that, we lost a lot of work. I mean, some people say that they wouldn't have gotten neural networks anyway because the computers weren't fast enough. I think we could have gotten them a decade earlier had we been working on them all that time instead of squashing the work down because it was an unpopular area of science. And this kind of deficiency in the scientific system in the human system. We have fads, and then we have like things that are really not cool for a long time. This is really impeding our ability to figure out these algorithms, figure out how the mind works. It's actually, ironically, because of a deficiency in how our minds work that it has happened. So I think we have a few of these algorithms, but it's going to be a long time for us to figure out all the right ones because we're actually being so stupid about it.
I want to echo what Luke just said, and I think that also implicit in what you said is sort of a pitch for Founders Fund in the sense that your favorite territory are the ones that other people are kind of ignoring, and the ones that structural incentives are misaligned around that prevent enough resources from exploring them.
What's the bottleneck though? Is it PhDs? Is it money? It can't be money.
Well, perhaps part of it has to do with our own intelligence and how we use it. So again, to bring it back to the human intelligence, our human intelligence hasn't increased huge amounts. We haven't made gigantic strides. We have all sorts of tools, as Steve Jobs described it. Computers are the bicycle for the mind. We are really able to improve ourselves through external things, but we really haven't improved ourselves internally. There is no pill that you can take that'll make you smarter. I mean, even with the technologies that exist right now, we could have kind of a moonshot for improving intelligence. So what that would mean is scan all the genomic profiles of all the people out there and try to get a bit of an understanding of the people who are really intelligent. Are there characteristics that we want to mimic? Maybe, maybe not, but that's at least something we can really start to explore. And we are starting to get the tools where we can actually make that happen on a human level.
Is this what Synthego is trying to do?
We're creating tools that will help researchers perhaps do these sorts of applications, but we ourselves aren't doing the applications quite yet. And the fact that Einstein existed is a proof point that we can have intelligence that's much greater than mine, definitely. And then I think a big question is, how do the tools evolve in conjunction with humans and human values? And how do we bring those closer together to create this superintelligence? So improve ourselves and improve the tools, and those working together.
And I'd add a third bullet point to that. I think it's a really interesting line of thought, which is improve the societal systems that are at play. Because I think we're so underutilizing the existing intelligence and human capital that we already have, and coming back to the question of why aren't we exploring these other areas? If you're a new PhD student in a top program, you have 9, 12 months to publish a paper, and you can only publish positive results, and it needs to beat a number on a standard benchmark, generally speaking. And so that means that your best strategy is to take last year's top method, make a bunch of incremental modifications, and then run it again and hope the number goes up a little bit so that you can write a paper. And if you want to explore some avenue that's going to take 3 or 4 years before it yields results, and it may be that it's not a fruitful avenue, that's career suicide and nobody does it. And so there's a really strong bias against taking risks. And I think that's part of what disincentivizes progress and causes us to underinvest in neural networks for a long period of time, and underinvest in other techniques that might be really fruitful avenues of exploration.
It's a problem of collective intelligence, is another way to put it. Humans actually, individually, have been, maybe they're getting smarter, this is the so-called Flynn effect, I don't know, but certainly they've been collectively getting dumber. Certainly, as academic science has progressed, we have more and more problems like this. Certainly, as democracies get bigger, they have more and more dysfunction. Certainly, and you have experience with the media, oh my God.
Agree, yeah.
It's not
so specifically the risk-averse aspect to it, or
I think there's a lot of different things that break down. But I think one simple way to put it is that there are we're designed for a tribe of 100 or 200 individuals, and our social machinery is designed for that. It does not scale very, very gracefully to thousands or millions of people, and so we get these hyper stimuli, something that normally would just be like, well, we should maybe stay away from that because that food is an unhealthy food, and so our tribe will not eat that food because someone got sick, becomes these sort of horrific taboos where like, this person did this thing and now it's bad, now their remarks are bad, they're really bad, don't anyone touch them ever.
And then there's a hype that comes into it.
And also then there's the hype we stay with tech companies in our world where all of a sudden this thing is exalted to godlike status.
Right. Whether it's a superfood or a neural network.
Kale will cure everything.
Yeah.
So a lot of challenges for the next kind of phases of AI. I mean, before, I want to talk a little bit about the role of humans next, because that's a key question a lot of people want to know about. But what are you most optimistic about the progress we're making in the field right now? Where are you?
For intelligence and coming from a biotech perspective, the capability for actually making modifications to genomes, that's finally happening. We've been able to read information out and understand to a certain extent, but we haven't been able to make modifications in a safe and healthy way. And over the next 5-7 years, that's actually going to come to fruition. And I think that's going to play in a huge amount to increasing our own capabilities over time, and then ultimately also directly interfacing with artificial intelligence. Whether it ends up being something like brain-computer interfaces or something else, I can't necessarily say, but I think there's definitely room for that.
We're modifying ourselves. We're able to for the first time.
In a safe way where we have positive proof points of people we admire, and we want some of those characteristics.
Anything you're excited about?
I actually think there's a great deal we can do with the more limited AIs that we have to take some of the things that humans do very badly and then take them off our plate and actually make us collectively more intelligent. So the more cars you have on the road, the more they crash. The more computer cars you have on the road, the better they drive. There are many kinds of effects like this.
Because they learn.
I think I'm similar to Luke's sentiment. I'm also excited for lots and lots of applications of narrow AI. We finally have the machine running that can fund more and more AI advances to the point where 0.5% increase in the effectiveness of ad targeting algorithm or some basic machine learning machinery can have a really tremendous impact on a company like Facebook or like Google. And that is what keeps investment happening into creating more intelligent algorithms. And so that's something that really excites me because I think we're going to keep seeing more progress made, or at least more emphasis on these questions being asked.
And where are you focused at Vicarious? Is it in those kinds of applications?
And it needs to be exploited like deep learning and like reinforcement learning. I think these are algorithms that are well understood, have been around for 20 years or more, and you can deploy them in all kinds of different settings to achieve results in healthcare and in all different verticals. And so I think that's great, and we should keep doing that. And I also think that we need a phase shift from these very simple models that are kind of like the old reptile brain or amphibian brain, where it sees some pixel inputs and performs an action to try and get a reward on a short-term basis, moving to something that has a causal understanding that water makes things wet, and that in order to unlock a door, you need a key, and much longer-term types of reasonings that involve a detailed cause and effect model of the world that is much more in alignment with the kinds of things you see in similar high-level mammals to us.
How's that going?
It's going well, actually. So I've been surprised by how fast we've been able to make progress, how interested investors are in this particular area, and in the kinds of results that we've seen so far. So a lot of our research at Vicarious, and we're going to be publishing some of it later this year, is in the area of when you're only given human-like amounts of data to train on. So like a couple of examples per category of, say, a type of image or something. And then you're asked to generalize to all different ways that a concept might present itself. So all different forms of the letter A, or all different types you might see a car appear in or something, being able to still recognize them and not be surprised and not get confused the way the sort of narrow AI techniques of today work. And so we've had some good results on that so far. I think that there's a lot more work to do. We're just getting started. And I'm excited to see where this particular branch of research leads. And I also feel really grateful to be part of a broader community of brilliant scientists who are working on solving these problems too. AI, and specifically super intelligent AI, is the kind of thing where the day someone creates it, anyone creates it, I think that we're all a lot better off as a civilization. And so I'm excited to be part of that.
Well, that's a great transition to the question, are we all a lot better off, right? I mean, how do we make sure, what are the role for humans? How do we make sure that the technology does develop in a way that the human population broadly supports and is bettered by?
There's two aspects that I'd propose to that. One route to making sure that we all end up being better off is making sure artificial intelligence is distributed. It's not just a single entity, one company, one person who really has the most powerful one. That's 100,000 times better than everything else. I think that ends up potentially not being a very good situation. So many people being able to influence potentially many AIs or even a single AI.
How do you make that happen when you have just some companies that have more resources, have more power, have more data? Google, Facebook.
This gets to the second specific approach, which is extending human capabilities so we're able to connect more closely and more easily to computers. So directly being able to essentially not necessarily read your mind, but be able to send your thoughts to the computer or get them back. And I think if everyone has this capability, that creates a huge market for narrow AI applications and ultimately the larger AI applications.
So you believe in the Elon approach, where you have to have a brain. If you don't have a brain interface, then the AIs are just going to keep getting better and better. Roughly, but if you have the tight brain interface.
If you want another discussion is, runaway AIs that aren't controlled by anyone versus ones that are more captive. I think the way to make sure they're captive or valuable to humans is to directly interface with them. So essentially, keep your enemies even closer than your friends.
I would love to add. So I think there's a whole universe of discussions to have about the far future where there are super intelligences and we're interfacing our brains with them, and this very hypothetical realm. I also think that there's a very concrete realm of near-term questions about what is the impact of AI on jobs and what does the future look like for the workforce. The way I think about that is in a different lens than I think a lot of the doom and gloom stories that I tend to read in the media, which is that we're so far from living in a Jetson society. And to get to a Jetson society, there's lots of things that need to be built. There are cities that need to be built, there are bridges and hyperloops and all kinds of new automobiles and drone planes and all kinds of stuff that needs to be built. And there's lots and lots of projects for humans to do. And the idea that we're going to run out of jobs because the AI will take them all seems really surprising to me, and unlike the historical trend of the Industrial Revolution, where it allowed people to make way better stuff, way more stuff, and make stuff cheaper so that everyone's quality of life improves. And I think that's something that can happen with AI, is where humans move from being the doers of hammering every last nail into the house in order to build it, to being a decider, a human foreman that supervises many robots in constructing something bigger than that human could ever construct by themselves.
So why do you think, why the fear mongering? I mean, so many members of the tech community too, though, and you mentioned Elon, but there are many others who are out there signing petitions saying, you know, we gotta build it a certain way, and Google can't be in control, or whatever the subtext is of there.
I mean, I think there's to put it more pointedly, I think there's actually a very small number, you could probably count it on a couple fingers, of people who say that kind of thing. And they all kind of say this.
A couple hands.
Maybe a couple hands, perhaps, yeah. But I think that there's one kind of group of people that's relatively small, that is also relatively low on the expertise level, that's making those kinds of claims. And I think that we should have a discussion and get to a consensus as a group together about what are the risks and what does make sense. Because I think there's a lot of, whenever you don't understand fully how technology works, it's easy to imagine it going awry. Like when the steam engine was first invented, they had all these fears about steam-powered machines taking over towns and hurting villagers and stuff. And it was because people didn't know what a steam engine could do and what that would actually mean. But when you really understand it, it's much more clear what it does and how it benefits society and how to make ones that are safe and don't hurt people and so on. So I think that kind of dialogue would be really good and would help us get away from the sort of fearful stories that tend to get echoed around through the media.
Yep. To bring it back to the previous discussion, I believe we're in a place where we have a lot of use those.
Yeah.
And where we invest our time and effort, so if we make drones that kill people autonomously, that's the type of technology we're going to end up with. If we make surgical robots that can do perfect surgeries through a tiny little orifice, that seems like a really good AI to sort of build. And those are the types of applications I would want to encourage. And that's what we need to talk about right now.
Yeah, amen. And I would add one more thing to that, which is the autonomous weapons piece, to me, is the scariest thing and the worst decision I think a government could make is build an autonomous army. Because we as a society are so bad at making software that is free of bugs and security holes. And so your army becomes somebody else's army with just one buffer overflow or one security flaw. And so just that's something that really, really kind of disturbs me about the strategic thinking behind building autonomous weapons. It just seems like a very bad idea.
Yeah, there's a fantastic movie I recently on this subject by Alex Gibney, on the subject of cyber war and cyber security, and it is quite troubling how easy it is to break into infrastructure and how countries are currently actually have active cyber war campaigns and have the ability to do this stuff. So it doesn't matter what we do with these things as a society. At the same time, I don't completely discount some of those, people counted on two hands. I think we need to be thinking about things further ahead. But what I do disagree with them is that I don't think we should be fear-mongering. And this is an area where, again, if you think about how society's organs of information processing work, the ones that are the largest collective systems, I think they're collectively the stupidest. So I don't think we should be designing the AI, and again, I'm sorry, but you started your own media companies. I don't think we should be using the media and Twitter to set the priorities of how we design AI, and that's what we're doing today. Yeah. I don't know what kind of... mostly I think they're just fair.
Right? Yeah. Is that because, and we haven't talked a lot about regulation, right, but people don't have to listen to it.
No, of course they do.
But it's so fun to talk about and imagine. There's so many movies that are made about it. So why, you as a reporter or as a media outlet, your job is to turn eyeballs into ad dollars. And so if you
actually
not hers.
Well, technically you as in the broader media, like that is the business model with some very narrow exceptions. And so, how did the story travel? And if it's about robots taking over, then the story traveled pretty well.
But so I get how the narrative gets blown up, but what, on the other side of the fence, why is the community itself so responsive to that? Is there a stigma? Is it...
Again, it's these human instincts. We're talking about something and describing it like a god. Of course, that brings in very, very basic parts of the human psyche, and they begin to think, God, someone is building a God. Well, should I worship it? Should I fear it? Oh my God, it's
but the scientists, you guys know what's getting built. I mean, so to the point of needing to harness this collective development to drive it forward, it's not clear to me why the media would stymie it. Now, if the media prompts regulatory interference or something, right, that might
sure it could. And I would say I would not just, because that's the most fearful part of its, is the political system. But then I don't discount how it affects engineers. Engineers are affected by the stories that are told in the media about the companies and the projects that are out there. And so talent will flow in certain directions and be motivating stories. And I don't mean, of course, like there are founders where they're the quintessential most independent thinkers. Like, Scott would have built his company his way no matter what. And that's why we liked it, because it was so different from an approach. And Paul's company as well, very, very different in their approach. But then the next people down and the next 100 people, they actually do respond to the public discourse in how they think about things. And I'm curious if you guys want to say that, if you disagree with me on like the employees, they don't care, or they're not affected by it at all.
I think everyone's affected by it.
I mean, it's the narrative in the society.
Yeah, and I also think that there's this problem that happens. So like Stephen Hawking, who's this incredibly smart guy, had comments about how AI safety is a long-term priority. One gets you more page views and more clicks, and it's sensationalist, and it's easy to write that article, and that's the article that most people write. And, the day of Facebook posting stories and seeing how many people share them, the story that gets written and the story that gets read is the one that has a sound bite that gets people excited. It's the BuzzFeed complex. And so I think that's the kind of byproduct of the society we live in. What I'd like to see happen is, a very boring conference of people who are scientists who rigorously study this the way we have scientists who study super epidemics and asteroid collisions. Like, no one writes news stories about those things very often. But there are scientists who study them, and that's a really good thing. I
just want to plug one of the things I want someone to solve, and want someone to solve an AI with, is in fact this exact problem of the BuzzFeed, the Facebook multiplication effect of particular memes. Mm-hmm. Now, this might be up to Facebook and Twitter to do, and I don't know if they'll do it. I know they're thinking about it. But it might be up to another entrepreneur to go figure out, to look at how ideas spread in our society using our modern digital media and see what would be the wisest and best way to inform people. How would you filter things? How would you apply AI and an algorithm to have the information that is going to have the influence where it's going to lead people to better decisions? I don't know anyone who's doing that.
If a tech company did that, it would be like conservative gate times 10,000 at Facebook, right? Because you have to be a neutral platform.
Oh, it'd be super politically incorrect. Yeah. But it's not a neutral platform.
Of course it isn't.
It's not.
But that's what they say.
Anyway.
Scott, you said something that I'll come back to it when I remember. But back to the interface. So we were talking about our brains connecting to AIs. I mean, before our brains get there, what are the other kind of interface improvements or developments that you guys think are on the way or need to happen? Because that does seem key to kind of getting to the next level.
We've got megabits of I/O in our current senses right now.
Input.
We have
megabits of input. The output is not that great.
We have the ability to put it out of the human body, but all it reads are little clicks and swipes. Right. And so I think
voice is that
a voice is a few kilohertz, but I think that when we get to I think that VR is actually going to drive for us creating a better interface. And when we're able to immerse ourselves in those worlds and fully use every bit, when you speak to a human, they use their whole bodies to communicate with you. Imagine if you were communicating with a computer, and the interface of the computer takes into account you're entirely immersed in using your entire body, and you're also using your voice. That's the natural way to communicate with humans, and one day we'll have the computers.
New computer systems. I think, Scott, you had some ideas about this. Basically, the next generation of computation.
The next generation of computation?
Sorry, in terms of personal computers, I think you mentioned this a couple of days ago when we were talking. There's no Steve Jobs out there thinking, what's the new interface?
Oh, I don't think this was me.
Because someone has to redesign these systems for this VR world, and it's not Apple right now. I mean, I know all of them are working on things, but
the natural interfaces that we already use will probably,
yeah.
There's so much communication that happens other than just with words, right? When you're sitting next to someone, that being emulated and understood is, I think, a huge, very valuable aspect.
And this kind of ties back into the renaissance we're seeing right now in conversational agents and bots. Facebook's M. There's a bunch of other companies that are working on Amazon's Echoes. You know, this whole renaissance happening right now in dialogue systems, and I think it's pretty interesting.
Yeah, what do you guys think of the state of those? I mean, personally, I think they're still incredibly basic.
Yeah,
I can wake myself up with my Echo.
But it's promising. Yeah,
what's promising that?
Well, I think dialogue is a really natural way of interfacing with systems. I use Siri, you know, probably every other day to do something. And I think that the more responsive our technology becomes to the way we naturally interact with each other, I think that the more seamless it becomes and the more it disappears from our consciousness and becomes an extension of it.
Yeah, imagine one day that computers, as they become smaller and as these interfaces become more natural, using the voice and using the body, there won't have to be any computer. You will just have, also assuming that you could project things directly to contacts or eyeglasses, like you will just have computational objects in the air. And
how far away is that?
Well, the tech already exists. You have things like HoloLens and Magic Leap, but they're very big and clunky. I think for mass consumer adoption, we're going to have to make it small, and that's at least 5 years away to be able to make these things small enough.
Just 5? That's
at least 5 years away to be able to make them small enough.
That's a minimum.
minimum, yeah.
I might argue that some of those, like the idea of a computational object that's in space, that's going to be at the same time scale as which we start actually developing brain-computer interfaces that are safe, that are reversible. That basically, you imagine, again, taking a pill, and you go into your VR system and you start training. Well, what kind of augmentation for my intelligence do I want? Do I want to be able to do any type of math? Do I actually want to have feedback into my perceptual system and have a little overlay on what I'm seeing?
Perfect recall.
Yeah, perfect recall.
Do you think humans should get to decide that? I mean, do you think that individuals should, it's sort of an ethics question, right? But what about individuals who can't afford it and yada yada?
Yeah, so these are huge, huge problems. I think ultimately it will be accessible by everybody. And I think you do ultimately have to trust the system that we're in, and you have to trust yourself and the people that are around you. Otherwise, you can't really get anywhere. I mean, there's structural problems in the system for media and information distribution, and maybe those will continue to be addressed, and we'll be at a point where we're actually mature enough as a society to have this conversation and actually make the appropriate decisions about it. Right now, I don't know if we are. We still have a decade.
What do you guys think about that question?
I think we need to get this stuff rolled out as fast as possible. We have some idiots and criminals running the society right now, and we need to upgrade them as fast as we can.
And who gets to decide who gets upgraded?
We need to upgrade the people that it's most important for society to upgrade.
It's determined by?
I would start with, okay. It's important for the technology to be distributed as widely as possible. And by using the mass consumer economy, digital technologies tend to be distributed as widely as possible. I actually don't think there's going to be a problem with that. I think this stuff is going to get out, and it's going to get produced cheap, and it's going to get out. I think actually it will be our fears, sort of probably religious or spiritual issues people have related to it, and also regulatory fears and issues that will prevent these kinds of devices from getting out as quickly and as broadly as they can. That's the risk. It's not going to be a rich-poor divide. It's just going to be like, can we get this stuff built at all?
Will the FDA approve the smart pill?
Yeah, and then therefore will anyone fund it? And so there's a huge chicken and egg issue, which is why some people are just calling for like a Manhattan Project effort to just screw it. We need to get like $1 billion and go try to do it.
Very exciting. Any thoughts on that?
I'm waiting for the point where I disagree.
Okay.
I think there's a lot of work that we, as a society, as a civilization, as individuals, can do to help accelerate progress, and there's a lot of impediments too.
I do want to say that one aspect of the sort of the conservative religious traditional angle that people might come in about I think there is a risk in upgrading humans. We could do it wrong. Like the stuff that we have announced in the world's got a lot of problems, but it's hanging together. Like
it needs to be a reversible upgrade. That's the key.
Yeah.
And that actually has a whole bunch of implications.
I mean, I think that this may be an area where we disagree, but my expectation is that we'll be able to make faster progress on AI and AGI than we will in biology, just because you have full visual understanding of the system, and it's something that's grounded in mathematics. Whereas when you're working on biology, it's very complicated.
Right.
There's all these secondary effects, second order effects, third order effects. It's very unpredictable, and it's also, you have to wait for the experiment to finish. I think that's actually a really major point. Because when I'm doing some AI research, or someone's doing some AI research, we get to control how fast time passes, and we can actually make time pass in parallel. So if you want to run 1,000 years of simulations and get the results in 5 minutes, you can do that with AWS and these other computing platforms.
This is the key problem to solve, and that's why we started Synthego. We want to solve the duration it takes to get that research loop closed, and the scale at which you can do research.
Yeah.
You should be able to do experiments times 1,000, times 10,000 with just one person.
On a molecular level, you'll be able to do it with Synthego, but if what you're talking about is doing that research on modifying aspects of a brain, you're not going to have 10,000 human brains.
The technologies do scale, and you can envision a scenario where you actually sandbox parts of it, and you can do an experiment and remove it.
Maybe sandbox parts of neural tissue or something like that and do experiments on
it. And this route is actually a valid, feasible way. There's a lot of tools and techniques that need to be developed. CRISPR and genome editing is the first step. We think that's going to take over and be big within the next year or two. And after that, there's several rapid iterations that can continue. I think within 10 years, we'll start getting the tools where we can do the types of experiments we want.
Yeah, I guess one of the risk boxes that I would put there that I'm curious about is those experiments that work well in Petri dish or in the confined setting, from what I've read anyway, when you try and scale them to the full mouse or to the full pig, or then finally to the full human, there's all these points where it fails, and it just takes a really long time to grow a monkey or a pig or a human. And you really got to make sure that you don't make a mistake when you're working on more intelligent animals. And so if you get everything right on the fast distributed system for testing these things in the lab, testing them on the humans.
The lab enables you to build the tools that then enable the tests on the human. So you could actually run 1,000 or 10,000 tests on a physiological body that's been developed. So if you have a cancer, you could partition off components of that cancer and test therapies times 1,000 simultaneously. This is like pretty far out there, but the tools to even build that system don't exist. And so first we have to build those, then we have to build the techniques.
But what if you want to know the effect 10 years later, 20 years later?
So it needs to be reversible. So if there's an effect, you can start removing those components.
Can you simulate aging?
We already have a lot of simulated aging, meaning there's a lot of old people. So.
Yeah, but like if you're developing a cancer therapy and it has it's really great on the cancer, but it actually dissolves the muscles of the heart over the course of 10 years.
Sure.
Then you need a whole body, and you need 10 years in order to tell.
But you can start cutting away the things that become risks, so that your clinical trials, instead of being 7 years of FDA approval, it ends up being maybe half a year. And it's a final step that you think you've got like 90% confidence it's actually going to work.
Yeah.
Right now, when a drug starts, it's low. It's like a 10% confidence, 20% confidence, and they poured billions of dollars into doing it. So that's a big conversation in terms of the structure of that system.
One of the points is reversible thing, which sounds like a great idea, but I just don't think in practice it happens with technology of any kind. I'm just imagining what is happening with mobile technology and social networking already, how much that has changed society, and even how much it's possibly changed the human psyche.
I see.
We're not going back from that.
I mean reversible on the scale of a human. If you decide you don't like this upgrade, you can go back.
Yeah, I can delete my Facebook. I thought about that yesterday. I can't. I can't fucking delete my Facebook. Excuse my French.
But here's the thing. If it's reversible, that means it's also upgradable. So you can remove it and get a new version.
Yeah, but how many biological reactions or chemical reactions are really fully reversible?
It ends up affecting the organism, but what you need... So we're talking in very generals. If we want to talk about this more, let's talk about a specific case.
Yeah.
I don't know if that's where we should take the
Can we reverse CRISPR?
You can potentially reverse a genome edit, yes.
Okay.
And that would be the kind of the baseline fundamental mechanism.
Yeah,
but
and that exists.
You can do a gene edit that would basically remove the gene you either inserted or put a gene back in that had previously removed.
Yeah, I just wanted to check on the word potentially. I just wanted to know, like, is it?
Yeah, I mean, that's part of how good CRISPR is right now. Synthego's first focus is to make CRISPR really, really, really good.
Yeah.
So you can do this.
Okay.
Right now, you can do it like 95% certain.
Okay.
You don't want to do that in humans yet. But then there's a lot of tools. So let's paint a specific concrete scenario. For brain-computer interfaces, you go in, you get a blood draw. At the lab, they modify your cells, you get them put back in, and over time, you'll get a neural net that starts building, and it's in basically similar to your brain anatomy, except it's a orthogonal signaling communication pathway. So it doesn't actually communicate directly with your brain, except where it hooks in. And the way it grows, is actually trained through a VR environment. So you get to train the capabilities and the superintelligence you want. And then if you want to remove it, what you do is you take a pill, and all that can basically get deconstructed. That's the type of thing that I'm describing.
But like, because the way the brain plasticity works, as soon as it's performing a function for you, the cells that used to do that for you die.
Yeah, that's readout only in this case.
Right, but so if you're constantly reading out of there, the cells that aren't firing that you used to read from, aren't they going to atrophy?
Your brain will work normally, and this is like a secondary system. It's like a JTAG port or a monitor on electronics.
So this is hypothetical, right?
This is hypothetical.
Yes,
this is 10 years.
Right.
Well, we're trying to figure out. Can you make it in 10 years?
Yeah, but the point being,
this is crazy stuff.
it seems like it could be reversible, but we don't really know.
If I were making it, I would make sure it's reversible first before making it the rest of it.
Got it.
So how about that?
Okay. Wonderful. Well, so we have a couple more minutes. What haven't we covered that you guys think is top of mind, important part of this conversation, what keeps you up at night?
I would say the thing that keeps me up at night is kind of just being, especially in the mainstream and also the research community, just being really aware of oversaturating on particular techniques. Like, I think that if you look at the distribution of papers submitted to NIPS or some of the most recent conferences and what method are they primarily using, we've really lost a lot of biodiversity. And I think biodiversity is important because we aren't, if we were really close to AGI and we had, we're almost there, then I think it's fine to really put all of our eggs in one basket and emphasize that. But I think that because there's still a lot of uncertainty about the core methods and core techniques that are going to get us there, I think that we should make sure that we keep other approaches alive and make room for testing out more novel hypotheses and taking some more risks. I think that's a really healthy thing, and I don't want to see that lost in the community.
Scary.
One thing that keeps me up at night is the fact that we have all sorts of really horrible diseases that still exist, and we don't necessarily have a scientific research platform or paradigm that has any chance of curing most diseases in the next decade or two. So I think that's very important to work on, and I'd say more people need to be working on that. That means more automation, more information systems in biotech, and ultimately AI helping us do the research also.
What keeps me up the most is actually this collective intelligence problem, and as human society scales far, far beyond the Dunbar number of 120 people per tribe, and as our connectivity scales, we weren't aware of people and what was going on in the next town, a few thousand people over, the next million people, the next billions, which we now have connected. Right now, I really think collective intelligence is going down. The mass systems of computation that we have, the media, democracy, capitalism, all of these things are functioning less and less well. And if we don't fix them, science as well. Like academic science is one of these mass computation systems. And as it becomes bigger, these problems that you see with NIPS, these fads of now we only do this one thing, it's the only thing. It makes no sense. Someone needs to crack this problem. Or else, way before we have an issue with, either Terminators, RoboCops, or whatever, we're going to have an issue with just the normal humans.
We already do, and I think it's something we're fighting against in terms of human biases. I think about Facebook. When I look at one of my other friends' Facebook feeds, it's showing completely different content that's actually really tailored to their biases, and just like my content is tailored to my biases. And I wish there was a setting I could flip that said, actually show me content. Show me content I disagree with.
Oh yeah,
I'd like to
actually
really
just an option for that.
Yeah, so show me content that I most likely to downvote or something. Like I wish there was some way to promote a diverse information diet, because all of the algorithms we're using today are ones that show you more of what you already like, and a narrow sphere around that, and that's really worrying to me.
I have to force
there's an
myself to do
opportunity
this.
for it. I mean, I'd sign up for that service.
I've noticed when I do this, by the way, and this is like for anyone consuming lots of media, like, and notice this is happening, and go and be like, okay, I really don't, notice the feeling you have, I don't want to look at it, but like, let me go find the people who disagree, and like read it for a little while, and be uncomfortable, but like, we don't get that anymore.
No, we don't.
As an entrepreneur, that's also really important information. You got to get your friends who say, this is not going to work. Let me tell you why.
So we have a lot of businesses that we need to create and crack, and so we can get working on all this stuff.
That's a bit of our perspective. Obviously, there's government, there's society in general needs to have a conversation, but as entrepreneurs, we're probably talking about that side of things more.
Absolutely. Well, thank you guys so much. This was a fun conversation, and look forward to the next one.
Great, thank you.